Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, let's have a look at a few exam questions. So this is part B of the 2017 question. A square has sides of length 2 centimetres. The midpoints of the sides of the squares are joined to form another square. This process is continued. The first 3 squares in the process are shown. Find the sum of the perimeters of the squares if this process is continued indefinitely. Give your answer in the form a plus b root c centimetres, where a and b is an element of ABC is an element of n. Okay. So indefinitely. So, and we're looking for sum of perimeters. So this is a sum to infinity of a geometric series. Okay, they are the key, the words in pink, they are the keys to figuring that out. So let's write out our sequence, because from the log tables, we can see that the formula that's important, page 22, is sum to infinity. Sum to infinity is equal to a over 1 minus r. So I need the first term of my sequence a, and I need my common ratio r. So that's why I need to write out some terms of this sequence. So term 1 will be the first perimeter. So it's 2 plus 2 plus 2 plus 2. Okay, so perimeter. So this is T1. 2 plus 2 plus 2 plus 2, or of course 4 by 2. So it's equal to 8. Term 2. So term 2 then, it's a square, so I need to work out the length of this side here. Okay, so this is my second term inside. Okay, so if I get the length of a side, so the other square is drawn from the midpoint, so therefore I can write down that this side here is 1 centimeters. And of course, so is this, because it's a square, okay? And that's because it's told me the new square is going from the midpoints. So this is a right angle triangle. Squares have right angles, so I'll use Pythagoras' theorem. Okay, so c squared is equal to a squared plus b squared, or c squared is equal to 1 squared plus 1 squared, which is 2. Therefore, c is equal to root 2. So my second term, T2, then is root 2 plus root 2 plus root 2 plus root 2, because each of these sides then, because it's the same thing, because it's a square, each of them is root 2. So that is 4 root 2. And of course, you can work out T3 if you wish, but you don't have to. So T3 then would be this little square in here. And if I just change color, this side here, okay, it belongs to this triangle. I'm just going to mark it in red. Sorry, going to be crooked. So this would be root 2 over 2, okay, the length of this side, or the length of this side. So just like before, c squared would be equal to root 2 over 2. So in other words, it's half of this side here, root 2 over 2 squared plus root 2 over 2 squared. Okay, let me put that into a calculator. So it's bracket root 2, bracket root 2 over 2 squared plus bracket fraction button root 2 over 2 squared. So I have got 1 for that. So if c squared is equal to 1, that means c is also going to be equal to 1. So therefore T3 is equal to 1 plus 1 plus 1 plus 1, so it's equal to 4. Okay, so my sequence 8, 4 over 2, 4, and so on and so forth. Okay, so therefore then if I do the sum to infinity, okay, let's work out r, my common ratio. It's equal to T2 over T1, or T3 over T2. it's 4 root 2 over 8, which is equal to, we put that into the calculator, 4 root 2 over 8. That's equal to root 2 over 2, or 1 over root 2. That's the same as 1 over root 2. Okay, but I leave it as root 2 over 2 because that's what the calculator gave you and it doesn't really matter. So I'm going to sub them into this formula here now. So s to infinity is equal to my first term, which is 8 over 1 minus root 2 over 2. Okay. Not as straightforward as I first thought. I just want to make sure that you get that error. Just bear with me now for a second. 16 plus 8 root 2. No, if you put it into your calculator, it does actually reduce down. Okay, so 16 plus 8 root 2 is what you get for the root to infinity. I'll tell you what I was thinking. This is an irrational number and you're not allowed to divide by an irrational number in maths, okay? So if you remember this from algebra, I'm going to write it in red. If you were to show the workings out of this, it would be 8 over 1 minus root 2 over 2, and you must multiply above and below by the conjugate of the bottom. In other words, you must rationalize the bottom. So what you do is you change the sign in the middle, you change the sign before the irrational part, and you multiply above and below by it. Below, the reason you do it below is that when you multiply it by its conjugate, the irrational parts will cancel. Okay, and then of course what you do to the bottom, you have to do to the top, so that you are in effect multiplying by 1. Any number over itself is 1. Okay, so when I looked at this first, I thought you were going to have to work this out manually. I was half expecting a maths error from the calculator when I put it in. So I thought we were going to have to do it manually, but no, your calculator handled it. So your answer is 16 plus 8 root 2.
If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.